Hi guys, this is Yashas M. I'm a student from Sri Venkateshwar College of Engineering. Currently, I'm pursuing Computer Science Engineering Artificial Intelligence course. I'm a third year student. Today, I'm here to present you a presentation on the continuous distributions. So let us go first with what is a continuous distribution. The introduction to the continuous distributions. The continuous distributions are a fundamental concept in probability and statistics, describing the behavior of random variables that can take any value with a given range. These distributions are essential for modelizing and analyzing a wide variety of real-world phenomena, from the height of individuals in a population to the flow of traffic in a city. The characteristics of a continuous distributions. It has been classified into three types. The first one comes the infinite possible values, smooth probability density, infinite subdivisions. Going to the infinite possible values, continuous distributions have a infinite number of possible values within their range. Unlike discrete distributions which have a countable number of possible values, continuous distributions can take any real number value within a specified interval. Now the smooth probability density. The probability density function of a continuous curve distribution is a smooth continuous curve. This curve represents the relative likelihood of a particular value occurring, with higher parts of the curve indicating more probable values. Now coming to the infinite subdivisions. Continuous distributions can be subdivided into a finite number of small intervals, each with a corresponding probability. This allows for a much more precise modeling and analysis compared to the discrete distributions with a finite number of possible values. Probability density function. The probability density function is a fundamental concept in the continuous probability distributions. It describes the relative likelihood of a random variable taking a specific value within the given range. The PDF provides a way to quantify the probability that a continuous random variable will fall within a particular interval. Unlike discrete distributions where probabilities are assigned to individual values, the PDF allows for a calculation of probability or interval or the range of values. The PDF is typically represented as a curve, where the area under the curve between the 2 points corresponds to the probability that the random variable will fall within the range. The shape of the PDF curve is determined by the parameters of a specific continuous distribution, such as mean and the standard deviation. Now let us come to the cumulative distribution function. The cumulative distributive function is a fundamental concept in probability theory and statistics. It describes the probability that a random variable takes on a value less than or equal to a given value. The cumulative distribution function provides a comprehensive picture of a distribution of a continuous random variable, allowing for the calculation of probabilities over any interval of the variable's range. The continuous distribution function denote cumulative distribution function, denoted as f of x, gives the probability that a random variable x is less than or equal to the specific value x. It is a non-decreasing function that ranges from 0 to 1 as x goes from negative infinity to the positive infinity. The CDF is closely related to the probability distribution function and can be used to derive important statistic properties of a distribution. The common continuous distributions has been classified into four types: normal distribution, exponential distribution, uniform distribution, gamma distribution. The normal distribution, also known as a Gaussian distribution, is a fundamental probability distribution in statistics. It is characterized by the bell-shaped curve and is widely used to model a variety of natural phenomena, from heights and weights to test scores and measurement errors. Exponential distribution. The exponential distribution is used to model the time between events in a Poisson process, such as arrival of customers at a store or the decay of radioactive particles. It is characterized by a constant rate of occurrence and is commonly used in reliability engineering and queuing theory. Uniform distribution. The uniform distribution is a probability distribution where all the values within a given range are equally likely to occur. It's often used to model situations where there is no preferred outcome, such as the roll of fair die or the selection of random number within a specified interval. And coming to the gamma distribution. The gamma distribution is a flexible probability distribution that can be used to model a variety of positive continuous random variables. Now let us go what is the normal distribution. The normal distribution is also known as a Gaussian distribution. It's a fundamental continuous probability distribution in statistics and mathematics. It is characterized by its bell-shaped curve and which is symmetric around the mean and is defined by the two parameters, the mean and the standard deviation. The normal distribution has several important properties, including the fact that approximately 68% of the data falls within one standard deviation of the mean, 95% falls within the two standard deviations, and 99.7% falls with the three standard deviation. This property is known as 68, 95, 99.7 rule, and it makes the standard deviation highly useful for modelizing, analyzing wide range of real-world phenomena. Now let us go to the exponential distribution. The exponential distribution is a continuous probability distribution that describes the time between events in the Poisson process, where the events occurs continuously and independently at a constant average rate. It's commonly used to model the lifetimes of electronic components, the waiting times between customer arrivals, and the decay of radioactive particles. The exponential distribution is characterized by a single parameter, the rare parameter, it is alpha, which represents the average number of events per unit of time. The probability density function of exponential distribution allows e power minus gamma x alpha x pattern where x is the random variable and e is the base of natural algorithm. Now let us go to uniform distribution is a continuous probability distribution that is evenly distributed. Now, applications of continuous distributions. The applications of continuous distribution are classified in three types: data modeling, quality control, and the finance and economics. So, conclusions and the takeaways of this presentation is: in this presentation, we explored the fundamental concepts of a continuous distributions, their properties and common examples. By understanding the principles of continuous probability distributions, you can effectively model and analyze real-world phenomena that exhibit continuous characteristics. So thank you for giving your time. Signing off. HSM.